Hello everyone and welcome to re-entry. In this video I'm going to go through the transposition and docking maneuver to kind of showcase how the Gyro Display Coupler works. So the Gyro Display Coupler, or the GDC, is kind of a backup platform to the inertial measurement unit, which is the IMU, the primary platform. So if the IMU fails, you can revert and use the GDC. However, the GDC can also be used for performing various maneuvers and as a tool during your mission. But the general good practice is to always try to make the GDC be equal to the IMU. So the IMU is currently now showing its attitude on the attitude indicator here. This is FDI1, and then this attitude indicator is FDI2. And the spacecraft is configured to show IMU on FDI1, the GDC on FDI2. And these two platforms are now equal. So let's go ahead. So I'm not going to go through all the procedures to perform a transposition and docking maneuver, but if you want to follow all the realistic procedures and use the CMC to perform the maneuver and auto maneuvering, you can follow these steps here, and you can go ahead and queue up all of these checklists and then just follow the steps on the checklist guidance system here. However, I'm going to do a couple of these procedures just to kind of showcase some of the key features here. So the first one is to ensure that our digital autopilot is correctly configured. And to kind of show you how this works, I'm going to add the DAP cue card and then go into verb 48, which shows me the digital autopilot configuration. And I can use verb 21 to set the configuration to whatever the checklist tells me. So 11103, 11103. And then verb 22 to set R2 to 01111. So 01111. There we go. And just to kind of quickly go through what these numbers actually means, these are parameters that configures the digital autopilot. And since we're going to be staging from the S4B, so if I go to external view, you can see the command module is now in front here, and then the S4B is on the back. And we're going to separate from it, and then we're going to turn around the entire spacecraft and then dock with it to extract the Luna module currently hidden inside it. So the parameters of our R1 is 11103. This means that we are going to be in a CSM only vehicle configuration. We are currently in number 3, the CSM and S4B. And then the next one is that we want to use quad AC for X translation. That is translation forward and aft. And we also would like to use the BD quads for X translation. So the A, B, C, and D quads are those reaction control system quads here, consisting of 4 jets per quad, and these are used to orient ourselves, change the attitude, and maneuver in space. So what this is saying is that we want to use all of the 4 quads around us for translation. Then the 0 there, that is the deadband. 0 means that we wish to maintain an attitude once we reach the target attitude of 0.5 degrees. So once we are at the target attitude, the digital autopilot will stop the angular motion and then try to maintain the attitude within 0.5 degrees. And the last one, number 3, is that our maximum rate during our turnaround maneuver, or in general turning around, is going to be 2 degrees per second. And then for R2, we are saying that the first parameter is 0. That is use BD for roll quad. That means that when we're rolling the spacecraft, we want to use the BD quads. and then the rest is set to use quad A, B, C, D in general. So now let's make sure that our docking probe is extended. So this is going to take 30 seconds to extend it. And these talkbacks above it show spark pull whenever the docking probe is in motion. So once this turns gray, we know that our docking probe has reached its extended position. Once it's done that, we set it down to retract. And once we hit the retract primary or secondary to up or down, we are going to retract the docking probe. But that's something that is going to happen once we've actually docked. So let's make sure that our jets are all powered for the auto RCS select. And then we want to set up the EMS, and the EMS is going to show us our delta velocity. I'm going to set this to -100, and this is just kind of a random number, but it was a common issue that EMS had some issues around being at 0, so now we're setting it to -100. Then we're setting this to delta V. And that's it for my procedures. So now I'm going to hit the EMS mode into normal, and we're in the delta V function, and our current delta V is set to -100. However, once we translate forward or aft, this will change based on how much we change our velocity. So you can use this as an indicator to show your velocity difference from the S4B. So with that set to 100, and everything is now set up, so it's currently monitoring any velocity changes, we can go ahead and separate from the launch vehicle. I'm currently in free, but I'm going to switch that to attitude hold. This will enable our digital autopilot, since we're now in CMC mode, and the CMC mode is set to attitude hold. This will enable the digital autopilot to control our jets. So the next thing that I want to do is to align my GDC, so this platform here, so that my current attitude becomes 00180. If I have that attitude, I can use that to align myself with 000 to help me get a perfect 180-degree turnaround maneuver. So if my current attitude is set to 00180 and I maneuver so that becomes 000, we should be looking directly towards the S4B and be aligned with its attitude. So how do we do that? So first of all, I want to view the GDC on this attitude indicator here instead of this one. So I'll set the FDI select to 1. And then I set the source to attitude set, because we're going to use the attitude set thumb wheels here to change the orientation of our GDC platform. And I'm going to set the attitude set to GDC. So with that, I'm going to then set the target attitude I wish to achieve. And you can click and hold this one, and it will go faster and faster until you release. So you have good control. So you can see that if I stopped and re-click, it goes slower, and then it goes faster and faster the longer I hold it in. So you can see that I've now set it to 180, and you have 0.2 degrees of accuracy on this one. So 180.0. And now I'm going to rotate this platform so that it becomes 00180. So with this configured, with the attitude set and wheel set, I can click and hold the GDC align to start driving the GDC towards that target attitude. You need to hold it in all the way until it's done. There we go. And with that, I can go ahead and separate. Translate slightly forward. Now you can see that I have separated from the S4B, and I'm slowly drifting away with about 1 feet per second from the S4B. And then I can reverse and get it back to -100, which means that I have now matched my velocity with a S4B behind me. And then I can start the turnaround maneuver. So I'll enable the COAS, and then I go into this view here. And all I need to do now is to zero out the attitude indicator. And since I'm now in attitude hold, I'm constantly holding down my joystick here to pitch up and all the way to 0, 0, 0. And since we now configure our digital autopilot to have a maximum rate of 2 degrees per second, you can hear that there's no jets thrusting right now, even though I'm holding in the joystick to its max detent. It will maintain 2, so now I'm just drifting towards that target. And once I release the stick, it will try to reduce the rates and then get back to the attitude it had when I released the stick, and try to maintain that attitude with a 0.5 degree of a deadband or accuracy. See the S4B coming up. Reach 0. Now the digital autopilot tries to find that attitude. And now there's a 45 degree offset between in roll. So now I can start to roll. And you can see that I'm only using these quads for roll. And there's also the 2 degree maximum of angular rotation. Now I'll get to 45 degrees, which you can use the roll index for. There we go. Now I should be perfectly aligned with the target. So now I'm using the translation to kind of center the target in the COAS. And now it's all about just closing in that gap. And you will need to do some minor corrections with the translation sticks. But if you do it like this, or use the digital autopilot and the full auto mode with a set attitude, you should only need to use the translation input while you close in. And just verifying, set to retract. And contact. Now that I made contact, I can go ahead and set this one to prime. and it will start to retract the docking probe. And once this is complete, I will set this to off. And that also takes about 30 seconds. Go. The next thing I want to do is to align my GDC with the IMU. So if I now take a look at the IMU here, you can see that the attitude on the IMU is showing this, while the attitude on the GDC is showing this. After I've maneuvered and modified the GDC, I would like to return it so it becomes equal to the IMU, because in case the IMU fails, I have the inertial platform stored in the GDC as well. So let's turn off the EMS and then go back into the attitude set. And then I'll go and open up the checklist. There's on the GNC General, you have GDC aligned to IMU, and I can run that checklist. Sure, we're in ATSET. Let's set the ATSET to IMU. Then let's complete the digital autopilot routine. Then I want to monitor my attitude. And now what we need to do is to adjust the thumb wheel so it becomes equal to this. So roll is 205.5. Now you can see the error needle is slowly coming into view here. So we set 205.5. And then let's set pitch to 56.3. Then yaw to 86.3. Now you can see that the error needles, they have aligned themselves. So this is my current attitude, and they are now matching the attitude set because I'm set the source to attitude set. Then I'll set the attitude set to GDC, and now I want to torque the GDC platform so it becomes whatever this attitude has stored. That means that I'm going to align the GDC with the attitude that I had on the IMU. And the same procedure, press and hold. Now they are quite equal, but they will not be 100% perfect with this method. I'm still working on that auto alignment, but you can take manual override mode while you're holding in the GDC button, and you go into, let's see, input controls, scroll down to equipment. Then you have a gyro slew roll, and you can use this to manually slew the GDC if you want. This is in case you're trying to reach attitudes that my auto logic is unable to reach. and if something fails. However, this turned out to be quite fine. And then the simplification here, if you don't want to do any of this while you want to align the IMU, there's a simplification that I made. In order to do so, let's go ahead and do our thing offset. Just move this into something random, like there. And then I'll switch it back to 1, 2. Then you have the warning here. If the FDI drive fails, set the attitude set to IMU, then GDC align, push and hold. So add set to IMU. And in this configuration, if I press and hold, it will automatically make them perfectly equal. Once you're done, go back to GDC, FDI source CMC. So that's how you can use the GDC during a transposition and docking maneuver, but also kind of covers how you can align the GDC to any orientation and how you can align it back to the IMU whenever you need to. So with that, thank you for watching.